This video is going to show you how to use StatCrunch to create a box plot and provide some analysis for your data. I have loaded a data set that I've used in the past. It's called mass data, and it consists of a lot of variables taken across several districts in the Boston area. School districts in the Boston area. So for the sake of illustration today, I am going to create a box plot for SAT math. So we're going to go under Graph, and we are going to pick BoxPlot, and we're going to scroll down to find SAT math, and there it is. I'd like the boxes horizontally, and I want to see both the mean and the median, and we're going to compute. So there it is. A couple of things we notice right off the bat, that if we hover over the green, that's the mean, and if we hover over the red, that's the median. So the mean is greater than the median, an indication that it might be skewed to the right. So we'll leave that for a moment. The important information is what I get when I hover over the box. It tells me there are 4 outliers, and we see that, too low, too high. Gives me the value of the IQR. The lower limit, which means the minimum. Q1, which is the first quartile, the median, which is 519, and Q3, which is the third quartile, and that is 548, and the upper limit, which would be the max, is 62. So you have all of the information you need to do a lot of statistical analysis. The only thing that is missing from this list of statistics is the value of the mean, but StatCrunch is the one that actually provided that. It is not typically part of the box plot. And the other thing that's missing is the standard deviation, and I can show you later how you can get that. So we've examined the box. Let's take a look at the outliers. I'm going to drag and put a pink box around these 2 low outliers, and they should be popping up in, here it is, Lawrence. Lawrence is a low outlier. And the SAT math for Lawrence was 404, which is a very low SAT score. And what would the other one be? It is Southbridge. And Southbridge has an SAT math score, average SAT score of 397. That too is a very low SAT score. So it's important to remember to clear so that you can go after the high outliers. Here they are. They're the high outliers. Let's scroll up and see who they are. Oh, Lexington. Lexington had a average SAT of 656. And what was the other high outlier? The other high outlier was Acton-Boxborough, and it had a math SAT of 649. Again, a very high score. Now what I'm going to do is show you how you can and we want to clear this, how you can show 2 box plots on the same graph. So I'm going to go under Edit, and I use a Mac, so I'm hitting the Command key, and I am going to add SAT reading to the variables. Same options. Let's compute that. So look at that. We have SAT math and reading on the same plot. What do I notice? Well, I notice right off the bat that SAT reading is got a little bit less, the value of the mean and the median are less for SAT reading. They are less. The whole graph seems to be shifted to the left. Reading actually they're kind of smushed together here, but it seems like they have 3 low outliers. I don't want to touch the fence there. 3 outliers for reading, and those outliers would be Lawrence, Randolph, that's a new one, and again Southbridge. So Randolph got added to the list. If we wanted to see what the SAT reading score was for these cities and towns, there they are. They are in fact low SAT scores. And there's one more up here. It is Lawrence. Okay, so we're going to clear that and go after. This is going to be tricky because I don't want to hit the fence. Just want to get the outliers. Okay. It says 4. Okay, 4. They would be Lexington, Harvard, that's a new one. Dover, Sherborne, we've seen that before. And Acton, Boxborough. So let's make sure we didn't lose any. Well, apparently my scrolling isn't all that it's cracked up to be here. Lexington, Harvard. Did I say Harvard? Well, Lexington, Harvard, Dover, Sherborne, and Acton, Boxborough. There's the 4. So you can compare variables by putting 2 box plots on the same graph. That ends my discussion of box plots and outliers. If you want to find a mathematical way of identifying outliers, that is called fences. And it would take a separate video for me to do that, and I will do that. So again, I hope this was helpful, and this ends the discussion of box plots and outliers.